So hello everyone, hi again. I'm Zuzana, I'm a malware researcher from ESET, and this will be a threat intel presentation about how OilRig keeps access to Israeli healthcare organizations and a little bit more. So just a refresher, we all know OilRig, the Iranian-aligned cyberespionage group active since at least 2014, also known as, yes? Sure, why not? Also known as APT34 or Lime. Well, this won't work. I'll just do this. Siamese kitten lysium APT34 targeting governments and other organizations in the Middle East. So we have been tracking OilRig for the last few years together with my colleague Adam Berger. Adam is not here today, but he's been the one leading the research efforts in our team, so credits to him. And this presentation will be about sharing a few observations that we made along the way while tracking the very frequent activities of this threat actor. And more specifically, I want to look at these activities through the eyes of three organizations that were targeted by OilRig: a local governmental organization, a group of healthcare organizations, and a manufacturing company. So these were all located in Israel, and all became targets of OilRig repeatedly over the last few years, every few months, whether it's their major campaigns, Out to Sea, Outer Space, Juicy Mix, or their new series of lightweight downloaders, which seems to be their tool of choice to keep access to some organizations' networks of interest, maybe in between campaigns. And by looking at these activities, we will see two main stories. So the first of them is how OilRig is persistent in targeting the same organizations again and again, or recompromising them just to make sure they have access to their networks and their secrets. And the other story is about what kind of tools, what kind of tactics this group uses. This is not one of the groups that would have one flagship backdoor that they would be improving and adding on capabilities, making sure it's not detected. This is not OilRig. OilRig has some backdoor, uses it for a couple of months, then tosses it away, creates a new one. Maybe there's some tweaks in the implementation, or it's the same thing, but implemented in a different way, some added things. Nothing sophisticated, a lot to track, but still we can see some patterns, we can see some interesting trends, and one of them is their recent shift away from the traditional CNC infrastructure towards using legitimate cloud service providers. So let's look at these things that re-emerge, but let's start with this Out to Sea campaign, just to have a common ground. This is one of the campaigns that was already published about enough. So just to summarize, this is a series of attacks between 2018 and 2021, where they were spread by phishing emails, and then this group went through a couple of backdoors throughout the campaign, typical OilRig. First, Danbot, which was already documented by SecureWorks, then Shark and Milan, documented by ClearSky. And when it gets interesting for our story is Marlin, which was first discovered by my colleague in 2021. And what makes it interesting is that it's the first time we see them using Microsoft OneDrive API for CNC instead of HTTP, HTTPS, or DNS that were used by the other backdoors. Another interesting thing we learned from this campaign is that's when we noticed OilRig has the habit of creating a lot of unnecessary folders and files on the victim's machine for their convenience, but it's usually unnecessarily noisy. And another thing that's interesting from this campaign is the selection of the post-compromise tools. One that I will mention is their custom Chrome browser data dumper called MKG, which we also saw in future campaigns. But you can read more about this campaign in our report. Today I want to focus more about what happened afterwards, what kind of activities they were focusing on. So let's first review their 2021 and 2022 campaigns. Then we'll get to the interesting part, their new series of cloud service-powered downloaders. And then we can tie it all together. So starting with these two campaigns, Outer Space 2021 and Juicy Mix 2022, These are two campaigns which were targeting mostly Israeli organizations. They have the same modus operandi but different tools, so classic OilRig. So we can review them both together at the same time. So they both started with phishing emails, which delivered a VBS dropper. Now the purpose of this dropper is to deliver an embedded backdoor. They're both similar. They even use the same simple string obfuscation technique using arithmetic operations and the car function. But JuicyMix also has another obfuscation layer on top. And besides dropping the backdoor, it also schedules the tasks for persistence and registers it with the CNC server. Now the next stage is a C# backdoor, a new one in each case, Solar and Mango. Similar logic, but enough differences to call them different tools. For Solar, this is a new C# backdoor with an astronomy naming theme, which is what gave the outer space campaign its name. You will see references to Earth, Mercury, Jupiter, Venus across the code. It runs on two in-memory tasks on a timer, which handle the main code for this early stage implant, which can download payloads from the CNC server, execute them locally, download additional files, exfiltrate, list contents of a local directory, and so on. So the primary task, Earth, is handling this backdoor side. What's interesting, one small detail, is that it uses this machine GUID value from the registry as a victim ID, and it creates a copy of this victim ID in a local file called SAN. So this is, again, something very small, but it aligns with what they've been doing previously. It's convenient, it's not really necessary, it's noisy, typical OilRig. Now the other task is called Venus, and it's responsible for exfiltrating files from a staging folder. Now when we look at the Mango backdoor, similar logic, a few things changed. So one of them is that this Venus task was removed, and the support for automatic exfiltration was removed. Instead, there is an additional backdoor command which can do just that. A visible change is a removal of the log functionality and obfuscation of the symbols. So instead of Jupiter as the function names, you have some gibberish. Then there is some other changes, for example, the use of native API instead of .NET API for executing commands from the CNC server. But probably the only interesting change is this unused detection evasion code, which was introduced. So in the function that handles executing the commands from the CNC server, this function takes an optional second parameter, which is a process ID. And Mango uses this process ID to set an attribute for the process to make sure that only Windows-signed binaries can load a DLL in this process. So in other words, a technique to prevent endpoint security solutions from loading their user mode code in that process. Now this technique was actually not used in the versions that we analyzed, but it's something that can be activated in the future. What's interesting with both of these campaigns, both of these backdoors use a compromised legitimate Israeli website for CNC. In the case of outer space, it's an Israeli human resources portal. In the other case, an Israeli job portal website. Post-compromise, they both use some version of a browser data dumper tool. We already saw this MKG tool used in the previous campaign. It's a C++ tool. For JuicyMix campaign, they use new C# tools, which can dump cookies, credentials, browsing history. They also use an obfuscated PowerShell script to dump data from the Windows Credential Manager. This is something we already saw with OilRig with other tools, with their hardparts campaign and others as well. But what's really interesting, and the most interesting to me, is this SC5K downloader used in the outer space campaign, because this is the first in the series of these new lightweight downloaders which use legitimate cloud providers for CNC. So in the case of SC5K, this one uses Exchange Web Services API for CNC server. And it's interesting because we also discovered 6 more versions of similar downloaders using a different variety of cloud service providers and alternating between C++, C#, in different variations throughout 2022. And we detected these in dozens of Israeli machines, including these 3 targets that are the study in this presentation. And because they were mostly discovered on networks which were previously targets of OilRig, I think it's something worth looking into in more detail. So let's look at these cloud service powered downloaders, starting with SC5K. So SC5K is a C#.NET application which uses an Exchange server account for CNC. It can be any Exchange server account. In the samples we analyzed, it was an Office 365 account with this email address sample check5000@outlook.com, which is how we named the downloader. But more importantly, they use this same account, and this account is shared between the attackers and then multiple victims, which all access the same account using the Microsoft Office EWS API. And how they communicate is through email drafts. So no email is ever sent out anywhere. It's just about creating an email draft by one party and then reading it, processing it, deleting it by the other party. So at any point you would access this shared Exchange server account, you could see 5 types of email drafts in that draft folder, and you could distinguish between different actions and different directions of the CNC communication by looking at if it has an attachment, what kind of file extension has the attachment, and also the extended properties of the email address, which allow you to define custom attributes. So for example, there can be a victim registration email which has some victim ID as the custom attribute named as G, just to let the attackers know that this victim is active and was last connected to this account on this timestamp. Then there's email drafts with commands, which have attachments with the JSON files, JSON extension, where you have a backdoor command that should be executed on the compromised computer. This also has the victim ID attribute so that the victims can distinguish between commands intended for them. Now, once that's downloaded and executed on the local computer, the downloader can also create another draft email with command output with a different type of properties to make sure the attackers can get the results. And then they can also use the same mechanisms to pass on payloads and other files, which will be dropped to a local working folder. Similar to the previous backdoors, this downloader can also exfiltrate files from a staging folder, again using a different type of combination of attributes to distinguish between files for exfiltration or files to be downloaded by the downloader. So this is just SC5K, just one of these cases where it uses an mailbox for the CNC and uses the Microsoft EWS API via the built-in Exchange service.NET class. So this is just one example. We have seen several versions of that, but it's not the only downloader of this kind that we saw. We also saw another version called OilCheck, which also uses emails to do the same thing, but in this case, it builds the API request manually to access the Microsoft Graph endpoint, again, communicating with the Outlook API. We also saw a few downloaders which use cloud storage providers for the same thing. So instead of emails, they could exchange this kind of information via files. Again, in this case, the requests need to be built manually. This is a C++ downloader called OilBooster. This is how it makes a request to the endpoint to, for example, create this keep alive file. I'm not going into details into here. It's very similar, just uses files instead of emails. Only one thing I want to mention is this small detail that when OilBooster is downloading and processing some payloads from this CNC server, from this shared OneDrive account, to decrypt and decompress the file, it goes through many steps and creates 3 files in the process. So it first creates the file on the local system, then reads the file, decrypts it, creates another file, then reads it, decompresses, creates the last file, and then deletes the first two. So again, it's quite careless. It's not really necessary to do it this way. It's quite noisy, something that we've seen with OilRig repeated again and again. So putting it all together, looking at these campaigns and downloaders and what we have seen in the last few years, what are the main points that we learn from tracking OilRig? Well, first of all, their operators continue to be highly active. Target organizations primarily in Israel using a selection of outdated and newly developed tools while staying true to their characteristic TTPs. They're not very sophisticated, but what they lack in sophistication they make up by this high level of activity, but they are noisy and they do make mistakes. They seem to be very persistent with attacking the same targets of their interests, which we see affected every few months, and we've seen this often, not just with these 3 cases discussed today, but we see this again and again. And finally, we see this shift from using traditional CNC infrastructure into using legitimate cloud service providers, which is a wise choice on their side because, of course, this makes tracking network infrastructure more difficult for researchers who don't have visibility into what kind of endpoints access these accounts. And also, it's easier to blend in within those organizations because, of course, these cloud technologies are ubiquitous in government and corporate spaces. If you are interested in more detail about this research, we are going to publish a blog post about the 2 campaigns anytime soon. In the meanwhile, thank you for listening, and if you have any questions, you can find me afterwards. Thank you.